Lecture number 3, rotational energy. For the rigid rotor model of a diatomic molecule, the Schrodinger equation gives the eigenvalues for the energy of rotation Ej as Ej is equal to, open bracket, h squared over 8 pi squared I, close bracket, j, open bracket, j plus 1, close bracket, for j equals 0 or 1 or 2 or 3 or 4. 2. Since Nubar is equal to delta E of Hc, it therefore means, open bracket, h over 8 pi squared Ic, j into j plus 1, three, that is, Nubar is equal to b into j plus 1. Here b is equal to h over 8 pi squared Ic, and is called the rotational constant, and has the same dimensions as Nubar. 5. For Nubar equals b into j into j plus 1, and b has dimensions of energy. Features of rotational energy. Selection rules. Delta J equals plus or minus 1. That is, J values can only change by 1 unit. Degeneracy. The existence of 2 or more states with the same energy. Here, it is given by 2J plus 1 states. Hence, J equals 2, second excited state. There are 5 states. Population of levels. Population. This is the number of molecules populating each rotational level shows a Boltzmann distribution with the number of molecules Nj in any level being related to temperature by Nj is proportional to exponential, open bracket, minus Ej over Kt, close bracket. If we take this degeneracy into account, the population of Nj level will then be Nj is equal to K into 2J plus 1 exponential, open, minus Ej over Kt. K is a constant. Rotational energy transitions. Substitute J values in Nubar equals Bj into J plus 1 gives, for J equals 0 to J equals 1, Nubar is equal to 2b. For J equals 1 to 2, Nubar is equal to 4b. For J equals 2 to 3, Nubar is equal to 6b. Hence, Nubar is proportional to J, where Nubar is the wave numbers of absorbed radiation. Results: a simple rotational spectra with separation between successive rotational lines equal to 2b, always. So delta Nubar is equal to 2b. And here we see the diagram of it. That's from there to there is 2b, from there to there is 2b, from there to there is 2b, from there to there is 2b. And that represents J equals 0 to J equals 1, whereas that represents J equals 1 to J equals 2, and that represents J equals 2 to J equals 3, and so on and so forth. Whereas the level of the energies is 0, 2b, 6b, 12b, 20b, and 30b for J values as shown on the diagram. Points to note about microwave spectroscopy. We use monochromatic incident radiation, hence no need for dispersion elements. First, scan the wavelength range to get one with maximum detection for use. Use gaseous samples. They give maximum resolution. Actual structural features easily observable for there is least intermolecular interactions. Here is a problem to try. Calculate the separation between the rotational lines of the spectrum of a gaseous 1H35Cl, given that the moment of inertia is 2.8 times 10 to the minus 47 kilogram meter squared. And here is the solution. The separation delta nu between the rotational lines is 2b, where b is equal to h over 8 pi squared ic. Therefore, delta nu is equal to 2b, which is equal to 2 times 6.626 times 10 to the minus 34, all over, open bracket and open again, 8 pi squared times 2.8 times 10 to the minus 47, close bracket, open another bracket, 2.998 times 10 to the 8th, which gives 2,000 per meter or 20 per centimeter. Isotopic substitution. This can be used to distinguish between two isotopes, for they occupy slightly different wavelength positions. For instance, HCl35 and HCl37, each of these will give different lines due to the isotopes of Cl.